Hello everyone. So today we will study Leibniz's test, and based on that test we will find the convergence and divergence of any given series. But before starting the Leibniz test, we should know the meaning of alternating series. So what is the meaning of alternating series? A series of the type u1 minus u2 plus u3 minus u4 plus means, as the name suggests, एक माइनस हो एक प्लस हो एक माइनस हो एक प्लस हो एवी जे सीरीज हो, then such type of series are called alternating series. Okay, and here all the terms are greater than 0. That means all the terms are positive, and such terms are called alternating series. Okay, so series of the type u1 minus u2 plus u3 minus u4, then they are called alternating series, and they are denoted by summation minus 1 raised to n minus 1 into un. For example, summation n equal to 1 to infinity minus 1 raised to n minus 1 is there, then its series will be 1 minus 1 plus 1 minus 1 plus 1 minus 1 and so on. Then such type of series are called alternating series. Example 2. If the series is in the form of minus 1 raised to n minus 1 into 1 by under root n, that means it is 1 minus 1 by under root 2 plus 1 by under root 3 minus 1 by under root 4 and so on. Means एक positive term हो एक negative term हो एक positive. Then such type of series are called alternating series, and then for such alternating series we use this Leibniz test. ઓકે, જ્યારે પણ આવી અલ્ટરનેટિંગ સિરીઝ આપેલી હોય ત્યારે આપણે લીબનીઝ ટેસ્ટ યુઝ કરશું. ઓકે, સો નાઉ વી વિલ સી ધ કન્ડિશન્સ ઓફ લીબનીઝ ટેસ્ટ. બટ વોટ આર ધ કન્ડિશન્સ ઓફ લીબનીઝ ટેસ્ટ? Then the first condition is, here each term should be numerically less than the preceding term. That is, un plus 1 should be less than un. Okay. It means કે preceding term કરતા જે next term આવે એ less હોવી જોઈએ. Means that કે આ term છે એ આની કરતા મોટી છે. Similarly આ જે term છે એ આની કરતા મોટી છે, આ જે term છે આની કરતા મોટી છે. Preceding term કરતા આ જે terms છે એ મોટી થતી જાય છે. Okay, means the series is decreasing. During that time, such type of Leibniz test is used. It will be more clear when we will solve the examples. And the second condition is, limit n tends to infinity un should be equal to 0. And finally, if you put the limit n tends to infinity in the given un અને જો એ 0 ને equal થઈ જાય, then the given series is convergent according to Leibniz test. If the un is equal to 0, then directly you have to write that the series is convergent according to Leibniz test. But if you put the limit and if un is not equal to 0, then the given series is oscillatory according to Leibniz test. Okay, if it is equal to 0, then the answer will be convergent, and if it is not equal to 0, then answer is oscillatory. So now let us see the examples of Leibniz test. So example 1. Test the convergence of following series: 1 minus 1 by 2 factorial plus 1 by 3 factorial minus 1 by 4 factorial plus so and so on. Here we can see that minus plus, it is the series is given in the form of minus plus form, means we can say that the given series is alternating. The first step you have to write is the given series is alternating. Okay, then after writing this step you have to write that the given series is in the form of, you have to write its form. Given series is in the form of minus 1 raised to n minus 1 into 1 by n factorial. You always have to denote it into this form. That is, as we discussed, that the Leibniz alternating series is denoted by this form. So you have to write minus 1 raised to n minus 1 into un, whatever the un is given. So here the nth term is 1 by n factorial, so it will be minus 1 raised to n minus 1 into 1 by n factorial, okay. And after writing it into the standard form, you have to write un. Un is 1 by n factorial. This is our un. And now we have to check the two conditions of Leibniz test. Now we will check the conditions. The first condition was that un should be greater than un plus 1. Okay. Means if this is our un and un plus 1 is 1 by n plus 1 factorial, then we can easily say that 1 by n factorial will be always greater than 1 by n plus 1 factorial. Okay. So first condition is satisfied. You can see here that આ ટર્મ છે એ આની કરતા મોટી છે. Similarly આ ટર્મ છે એ આની કરતા મોટી છે. આ ટર્મ છે એ આની કરતા મોટી છે. એવી રીતના જે first condition છે, that is un is greater than un plus 1 is satisfied. Okay. Now moving towards the second condition. What was the second condition? That we have to put the limit and check in the un. Limit n tends to infinity of un. So limit n tends to infinity of un is 1 by n factorial, and if we put the limit, then answer will be 0. And as we got un equal to 0, according to Leibniz test, we can directly say that the given series is convergent. Okay, according to the conditions of Leibniz test, both the conditions are satisfied. So we can directly say that the given series is convergent. Okay. So example 2. Show that the series summation n equal to 1 to infinity minus 1 raised to n minus 1 into n by 2n minus 1 is oscillatory. Okay, we have to show that the given series is oscillatory. It means કે આનો answer જે un છે that should be a 0 ને equal નહીં થતું હોય. એટલે આનો answer કેવો આવ્યો? Oscillatory. Now let us check it. First of all, we will write that the given series is in the form of summation. It is already given in this form. So we directly have to, this is our un. So we directly have to write un equal to n by 2n minus 1. Okay. So, and now we have to compare with the un plus 1 form. So we can compare it like this, un plus 1 minus un. જો 0 થી ઓછું થાય, then we can say that the un will be un plus 1 is equal to un. Okay, તો આપણે આ ચેક કરી લઈએ. un plus 1 minus un કરીએ, અને જો એ 0 ને equal 0 થી ઓછું થતું હોય, તો it means that it will satisfy this condition. So what will be our un plus 1? Then it will be n plus 1 by 2n plus 1 minus n by 2n minus 1, that is equal to minus 1 by 4n square minus 1. Okay, આ માઇનસ માં છે, આમાં આપણે કોઈ પણ વેલ્યુ પુટ કરશું n equal to 1 to infinity, any value, then it will be always less than 0. કેમ કે આન્સર છે હંમેશા માઇનસ માં જ આવશે. So as we got un plus 1 minus un less than 0, so we can say that un is greater than un plus 1. Okay, so our first condition of Leibniz test is satisfied. un છે un plus 1 કરતા મોટું છે. Now what was our second condition? The second condition was we have to put the limit and check. So limit n tends to infinity of un. So limit n tends to infinity. What is our un? That is n, and here from the denominator part, if I take n common, then I will get 2 minus 1 by n. This n and this n will get cancelled. And then if I put the limit, then I will get answer 1 by 2. So we can see that here un is not equal to 0. 1 by 2 is not equal to 0. And as un is not equal to 0, the answer will be oscillatory. Okay, so the given series is oscillatory. So example 3. 1 minus 2x plus 3x square minus 4x cube up to infinity is given. Now again we can see that the given series is alternating. So we have to write that the series is alternating. So we have to apply here Leibniz test. And now we have to write the form of the series. So the given series, the series is in the form of, you have to write the standard form, that is minus 1 raised to n minus 1 into n x raised to n minus 1. So this is the standard form, and so we got our un. So we can write that our un is equal to n x raised to n minus 1. Now we will check that whether the un is greater than un plus 1 or not. So for that we will calculate that whether it is less than 0 or not. So what will be our un plus 1? Then in place of n you have to put n plus 1. So here we will get n and x raised to n minus 1. You can put value and check. It will be less than 0. So we will get un plus 1 less than un. We will check the another condition, that is limit n tends to infinity of un. So whenever we will put limit n tends to infinity in the un, that is n x raised to n minus 1, then whenever you will put the limit and check, you will get 0. And as un is equal to 0, according to Leibniz test, the answer will be convergent. So given series is convergent. Okay. So now example 4. X by 2 into 5 minus x square by 2 square minus into 10 plus x cube by 2 raised to 3 into 15 minus and so on. So again the given series is alternating form. So we can first we have to write that it is an alternating series. Okay. And then you have to write its form. So the series is given in the form, series is in the form of minus 1 raised to n minus 1 into here in the numerator part we have x raised to n, and in the denominator part we have 2 square means we have 2 raised to n into 5, 10, 15, that is multiples of 5. So we can write 5n. So we got our un. So un will be minus 1 x raised to n by 2 raised to n into 5. This will be our un. So now again we will check that whether it is un plus 1 is less than un or not. So we will check this condition. So un plus 1 will be x raised to n plus 1 by 2 raised to n plus 1 into 5 into n plus 1 minus our un, that is x raised to n, and here 2 raised to n into 5n. Now if I take x raised to n common, then I can write, if I take x raised to n common from the numerator part, and if in the denominator part if I take 2 raised to n and 5 common, then I will get like this, x by n plus 1 minus 1 by n. Okay, and now if I take the LCM here, then I will get nx minus n minus 1 by 2 raised to n into 5 into n plus 1 into n. And now you can put the value and check, its value will be less than 0. So we can say that un plus 1 is less than un. So the first condition of Leibniz test is satisfied. So now we will check the second condition. And as un plus 1 is less than un, we can write that each term is less than the preceding term. Okay, you have to write this step in each example. Then we will find the second step, that is limit n tends to infinity of un. So limit n tends to infinity of un is x raised to n by 2 raised to n into 5n, and whenever if we will put the limit, we will get answer 0, and as we got 0, un equal to 0, so answer will be convergent. Okay, so the given series is convergent. So example 5. Show that the series 1 by 1 raised to p minus 1 by 2 raised to p plus 1 by 3 raised to p and so on converges for p greater than 0. Now again the given series is alternating. So the series is alternating. Okay. And the series is in the form of minus 1 raised to n minus 1 into 1 by n raised to p. So our un will be 1 by n raised to p. And again checking the condition. So we can write un plus 1 minus un should be less than 0. Then only we can say that it will be, this condition will satisfy. So we will check this condition. So 1 by n plus 1 whole raised to p minus 1 by n raised to p is always less than 0. So we can say that this condition is satisfied. So now we will go for the second condition and put the limit in the un. So limit n tends to infinity of un, that is limit n tends to infinity of 1 by n raised to p is always 0. And as the value is equal to 0, answer is convergent according to Leibniz's test. Okay, so the given series is convergent. So now next example. Use Leibniz's test to discuss the convergence of the given series. 1 by 2 minus 1 by log 2 minus 1 by 2 minus 1 by log 3 plus 1 by 2 minus 1 by log 4 and so on. So again we can say that the given series is alternating. So we have to write the series is alternating. So here we can apply Leibniz's test. So again our un will be 1 by 2 minus 1 by log n plus 1. Okay. And here you can see that un plus 1 will be 1 by 2 minus 1 by log n plus 2. So here by putting the values you can directly check that here you will get un is greater than un plus 1. Okay, so the first condition of Leibniz's test is satisfied. So now we will check the another condition, that is limit n tends to infinity of un. So limit n tends to infinity of, what is our un? 1 by 2 minus 1 by log n plus 1. And whenever you will put the limit, you will get answer 1 by 2. But 1 by 2 is not equal to 0, means un is not equal to 0. So answer of this series will be oscillatory. Okay. So the given series is oscillatory. So example 7. Check the convergence of the series 1 by 1 into 2 minus 1 by 3 into 4 plus 1 by 5 into 6 minus 1 by 7 into 8 and so on. So again the given series is alternating. So series is alternating. And then you have to write the form of the series. So the given series is in the form minus 1 raised to n minus 1 into 1 by, we have here 1, 3, 5, that is 2n minus 1. And here we have 2, 4, 6, 8, that is into 2n. So our un will be 1 by 2n minus 1 into 2n, and our un plus 1 will be 1 by 2n plus 1 into 2n plus 1. So that is equal to 2n plus 1 into 2n plus 2. You can directly put the values and compare it, then you will get un plus 1 will be less than un. So the first condition is satisfied. Okay. Now we have to check the second condition, that is limit n tends to infinity of un should be equal to 0. Then we will get the answer convergent. So limit n tends to infinity of 1 by 2n minus 1 into 2n, and by putting the limit you will get anything upon infinity is 0. So we got un equal to 0. So according to Leibniz's test, answer will be convergent. Okay. So now in this way you have to solve the examples of Leibniz's test. Whenever the alternating series is given, you have to apply this test. Now I have given 4 examples for practicing. Okay, this all are alternating series. So here you have to apply Leibniz's test. Okay. Do practice the examples of all the tests. Thank you everyone. I hope you all liked my video lecture. Thank you.